Welcome to this special episode of Frequency Matters, the RF and Microwave Update Series. I'm Pat Hindle. I'm here with my co-host Gary Lerude and special guest Satish Dhanasekaran, President of the Communications Solutions Group at Keysight Technologies. Welcome, Satish.
Thank you, Patrick and Gary. I hope both of you are staying safe and healthy through this time.
Satish, sorry we didn't get a chance to catch up at Mobile World Congress since it was canceled, but let's start off with an overview. Where does the 5G market stand now, including the effects of COVID-19 outbreak?
Yeah, Patrick, great question. I would say that it's still early days in 5G with tremendous momentum on the innovation front, the deployment front, and equally important is this runway of or a roadmap that's forming for the industry that I think will keep us all very busy for the next few years, maybe 3 to 5 years to come. I would say that the state of the industry in 2020, we have probably exited this year with close to 1 million base stations deployed with 5G capability, over 150 million handsets is the current projection, maybe more. A large amount of the deployment activity in China is accelerating at this as we speak today, including pretty good progress in Korea and Japan and the US. We see slowdowns in Europe as a counteracting force. But that's what's going on today. But if you zoom out and look at the big picture, most of the deployments right now are sub 6 gigahertz with let's say the non-standalone version of 5G. And I think the progress that we're going to experience over the next 3 to 5 years will be the adoption of higher frequency or millimeter wave, and followed up with, let's say, the standalone versions of 5G, as I think those are going to become necessities if you want more capacity and if you want more, let's say, better performing and lower latency network. Many countries of the world are starting to mandate latency requirements. And this tells you how important 5G is. It's not just making your smartphones, perform better, but it's about, providing the fabric for the new digital economy of the future. And I think that's a very exciting vision that is forming and is being realized. For Keysight, I think for us, it's always been a strategic priority for the company from day one to lead in 5G. We've made many acquisitions, as you're aware, which have enabled us to put out a industry-leading platform all the way from layer 1 to layer 7, both on all sides, both wireless and on the wireline side of the networks. And we're well positioned. In fact, in the first half, we've just launched 90 new solutions in the first half of the year, first half of our fiscal year, which starts in November last year. And we're continuing to innovate and engage with customers. The surprising fact, maybe through the COVID crisis, is how busy we have been. All of us engaged in 5G have, the intensity of customer engagements have been high. In fact, folks working from home created a little bit of a dynamic, but even that notwithstanding, we continue to be very busy and engaged with customers as they are progressing their schedules. And I expect in the second half of the calendar year, as COVID hopefully recedes a bit and customers come online and start to return to their respective sites, we'll see the activity set with 5G pick up even more.
Satish, dynamic spectrum sharing and integrated access backhaul seem to be key technology enablers for 5G. OpenRAN is another topic we're hearing a lot about, proposed as a means to reduce cost and an operator's dependence on a single network equipment manufacturer. What's your view of these and the challenges facing their adoption?
Let me point out to a few industry teams that you highlighted, Gary, that represent this dynamic roadmap that we see forming in the industry. OpenRAN is clearly a much more than just a technology. It's a business model transformation that has a potential to accelerate innovation on the RAN front. I mean, you think about traditional RAN being a monolithic block and of compute power and software and hardware that goes together, and that has limited operators, many of them, including Rakuten, who started to deploy this, have found that it has unshackled them from the limitations of being locked with one particular supplier. And the promise of OpenRAN clearly is you're now able to disaggregate the RAN into its fundamental building blocks, the radio, the baseband units, the connectivity between them, and the digital unit. And therefore, you're now able to source these capabilities from different suppliers in the food chain that enable you to go faster and deploy new features sooner. And I think that's the promise. And it's very exciting and interesting. The OpenRAN Alliance has started to see considerable interest on the technology front. The United States is taking, with the FCC, has taken a pretty strong interest in taking a look at this technology. I am part of the FCC's Industry Advisory Board, and we have taken a deeper look at how ready OpenRAN is to commercialize. And we've talked to multiple suppliers that are part of this forming ecosystem, starting with the folks that make CPUs, to GPUs, to software companies that enable this virtualization trend. And it's interesting and exciting in its possibilities. But my sense is it's still got some ways to go in fleshing out who owns the entire technology stack. In the case of Rakuten, they've already made a lot of investments, as you'll hear from Tariq when he describes it, in building out the entire IT stack that's needed to support OSS and other capabilities, so that they can actually deploy it. It remains to be seen how quickly multiple operators may be able to embrace that sort of approach to do it. But at the heart of it for test, it comes down to interoperability. Are we able to interoperate between different parts of the RAN that have been, just say, designed by different suppliers? And so that's a place where we believe we can play a leading role, and we are enabling the industry by providing OpenRAN capable tools and solutions so that they can progress this idea forward into a deployable one at scale. Dynamic spectrum sharing, DSS, is another, let's say, feature that's been implemented or has been introduced, I should say, in Release 15. And it facilitates a cost-effective way for operators to get on the 5G coverage schemes. And especially by leveraging the existing LTE spectrum, it's largely touted as a software upgrade by many suppliers, which has tremendous promise, because you can imagine if a network operator can switch seamlessly between 4G or LTE spectrum and 5G spectrum with a software upgrade. Obviously, that's got a economic appeal to many operators versus having to redeploy the spectrum or reform the whole spectrum or convert it into or buy a 5G spectrum, for example. And so that has some promise, but with that promise comes tremendous technology complexity as well. One is the base capacity of a network, could be lowered because you now have to schedule between the 4G and 5G spectrum, so you have some overhead associated with that. But in terms of looking at a static scenario versus a dynamic scenario, you could get 3 times larger throughput gain by going with DSS. So it depends on what your comparison metrics are. But it's clear that in DSS that there's complexities associated with the scheduler. The scheduling algorithms are now proprietary to the particular implementation. All of that has to be tested in the context of the whole system or the network and how it performs. And on the UE side, you clearly have to be able to handle, let's say, the numerologies that associate with 4G and 5G. For a 4G UE, there's not much of a change, but for a 5G device, there's tremendous change. So we've decided to take a holistic approach, and because of our ability to emulate both network and device in the lab, we've been able to create a DSS testbed for our customers where they can start to study the different mechanisms, study the different implementations of schedulers, and so that when they do go to an operator, they're able to show up with greater confidence. Interoperability is so key in this area. You can imagine a network with multiple networking companies that are part of that fabric, and devices implementations varies as well. So when you put all this together, you have to be able to generate and optimize your network. So there are some drive test tools as well that we have that allows operators to optimize their network. And but it is an exciting field that we think will gain a lot of promise, especially in regions where operators are CapEx starved. I think DSS gives them a quicker way to adopt 5G. The third area you brought up was IAV. which is again essential for FR2 implementations to have backhaul that can handle, let's say, the vast amount of data that comes in through a 5G network, especially when you're talking millimeter wave or FR2 implementations. And in the mobile use case where maybe it's not as viable that you just throw a fiber in there to sort of handle your backhaul challenges, IAB becomes more relevant. But it comes with additional challenges with interference that has to be mitigated or handled much smarter ways than previously. So tremendous complexity with 5G with all these underlying technologies. And that's the reason why we believe that the innovation in this field will continue for years to come, and we're excited to be part of it.
We've been speaking with Satish Dhanasekaran, president of Keysight's Communications Solutions Group. Satish, thank you for your time today and sharing your insight.